All right, so in this session, we're going to look at the details, components, and different aspects of usage of functions within Python. One important area that functions do is to interact with the variables. So there is this sense of global variables, functions existing outside of the, variables existing outside of the function that we have just defined, and local variables that will be the variable names that we define, we newly create within the function that we have just created. So the variables, for example, in this screen here, are x text deduction. All these are basically, here's my laser point. So x and text deduction, all these are global variables because they exist outside of the function. And profit, amount, x, and so on, they are all considered local variables. So first of all, let's know how to categorize them. And we learned about global and local variables in that sense. But here we are encountering sort of a new local, the local that is within the function itself. Now, we also see that there's this line here called global text deduction. Because if you don't have this and you write text deduction, it is going to flag an error because it's going to say you're trying to access a variable, a local variable. That means within the space of this function, there is no such variable named text deduction. And you're trying to access what is the value. That's wrong. But you say, no, but I'm trying to get this guy here, which is defined. It has a clear value of 100. Oh, to do that, you cannot just use it as per normal. You got to tell Python or within the function that inside my function, text deduction is a global reference, not a local reference. And you have to do that upfront. Because the moment you try to access it and then below you get a global, and that's wrong because it's too late. You have already, by merely referencing text deduction, you are already trying to imply that your text deduction is a local variable. So you must quickly as in the first instance, so the first line usually, right after the def function, you must inform Python that all our references to text deduction needs to be local, needs to be global, needs to not give me an error, but needs to refer to this thing. And if I were to change anything about text deduction within my function, I am changing this guy, not creating a new local variable, change it while referring to the global variable, all having the same name. No such thing. So a name, for example, text deduction, a variable name text deduction inside the function must be either a local scope variable or a global scope variable. There's no both, there's no simultaneity. Okay, so let's just, let me just copy and paste the code. And this is where I need you to work with me. So we'll create a new space and run a new Python. So I just pasted the code here, right? So we have global x text deduction. Define a function that uses the globally defined text deduction. All right, and we do that by the keyword global. And you can put a comma x, comma whatever. But notice that x is in our global definition, but we did not define x to be global. So by that, automatically, by default, all names that are referenced within a function in Python are all locally scoped. All right, so when we overwrite the x here, when we read this, if you're not aware, it can be very confusing. oh, you're overriding this 1, 2, 3, 4, you're going to change it. Not really, because notice that X is not global. X is local. So which means that, remember what's a variable is a container of values, right? We calculated profit minus amount, and that value is being stored in the container. Now, is this container the global, the container outside there, outside my function space, that is marked as X? Or is it a container I created in my function space that I incidentally refer to it as X also? Well, that's the latter case. So this X, even though it has the same name as the global X, it is local and it refers to a different container from that X. We talked about using family names and first names, right? So we may have John, right? Global John and a local John. So when I say John, it can be confusing, but because it is within the house of profit adjust, the house meaning this defined area, this function called profit adjust, there's only one John, so there is no need to be confused. It will never refer to all the Johns outside this house, this function. So here, because we did not say global space X, X or John is basically local. And there's only one John, so John will respond. Yeah. So this X is definitely not ambiguous, not confusing, and it will be profit minus amount. So it'll be whatever the caller sends us as profit minus auto by default 1,000, and that would be our X here. And upon returning X, we would not have changed the global container that contains 1, 2, 3, 4 is still 1, 2, 3, 4. So our profit adjust returns a value of X into Y. Y will have whatever X had earlier on. And whatever X had earlier on, once it returns, the entire scratch space, that means all the containers, all the variables, whatever it is, that were created due to running of the function would have been poof, gone, deleted automatically. We don't have to worry about freeing up the memory. Oh, just now we defined X, we better run a delete X or something like that. So that's the nice part of it. You just enjoy the space and leave. You don't have to do the cleanup, which is of course a chore, and Python does it for us all the time. Okay, but the value is being salvaged, is being transferred back. So we have a return here, which is basically saying the same thing, returning the result of X, of this computation, all right, back to the caller. And the caller is going to immediately store it into the global container labeled as Y, this variable called Y. Okay, so we do not have to, because the function returns X, we have to use X. We don't have to match. In fact, this ability to let us assign the value back to anything, any container, any name, is the most powerful mechanism here, right? So that we can, for example, ask our friend, our teammate, our groupmate to write this function. Hey, can we do split our work? You write profit adjust, I write the rest of the codes to integrate everything together. Okay, great. So when you write your code, you decided to initialize X to 1, 2, 3, 4. All right. But your teammate works best at 3 a.m. because he's a hacker, right? He works best at 3 a.m. in the morning and you are sleeping. He is not going to wake you up, neither would you want to be woken up, right? And ask, can I use the variable X? Because I really want to use X. And you're not going to say, no, 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 you cannot use X because I use it. And there will be, even if you're happy with being woken up at 3 a.m., there'll be quarrels. Why must you have X and I can't have X, right? So, totally no reason, no need to quarrel, no need to check even. You just use X because it's all local, completely safe, no cross referencing. Let's just run it. Okay, let's understand what's going on here. As we run, Python assigns these values, right? And when we run the def, remember def is just to tell Python, I want to build this code here. Don't run it yet. I'm just telling you, right? So you build a code here, and so on. We'll come to that now. Then we say print a global scope. That's our main space here. B must have been triggered by this line, and it says, what is X? 1, 2, 3, 4. Not surprisingly, it's correct. Then we try to assign a value to Y, but the value is kind of to be announced, to be calculated by this function call. So Python will pause there and run the function. So it will transfer one value, which is 1, 2, 3, 4. So our profit will be 1, 2, 3, 4. And it did not overwrite the default amount, 1000. So AMT, which is AMT and both AMT and profit are local variables. Changing them will not change nor define anything in the global space. All right, so it's all happening within the house, including profit and AMT themselves. So we now know profit is 1, 2, 3, 4, AMT is 1000, and Python is told whenever you see a tax deduction being referenced or being assigned, do it to the global container that is called tax deduction. So if I'm reading, if I'm referencing, go and check the outside. All right. If I'm assigning to tax deduction, go and change the one that's outside, not here, not in-house. Okay. So when we say print in profit adjust, and then the amount is 1000, and the tax deduction is, because it is global, it is going to read 100, which is true, right? We never tell profit adjust anything about tax deduction, but it knows it's going to look at a global variable. And X is now 1, 2, 3, 4 minus 1000. So 2, 3, 4. 2, 3, 4. All right. And then we get returning from profit adjust. And that's all. We return 2, 3, 4. And it's the 2, 3, 4 value that's being thrown out by the function, not the name called X. It's just the 2, 3, 4. You need to separate the variable name called X and the value that the container X contains. That's called 2, 3, 4. So return takes the 2, 3, 4 value and returns it back, sends it back to the caller, while discarding all the rest of the containers called X, called profit, called amount, whatever. Okay. Now, back to the caller, we were pausing the calculation in the global space by first jumping. Remember, every function call is a jump in terms of the execution sequence. So we jump into profit adjust. It can be located anywhere in the memory. It can be so far away that we don't know where it stays inside the memory space. It can be next door. We don't care. Python will arrange for the residence of profit adjust function. So we finish up the calculation, and Python brings back the 2, 3, 4 value. Immediately, it is told to assign to the variable y. And now we print. What's the value of x? It has to be 1, 2, 3, 4, right? Because nothing changes thanks to the declaration. All right, that global here is only including tax deduction, but not x. And what about y here? Y was being assigned 2, 3, 4, right? As we were following the execution, and so it's 2, 3, 4. So that much is clear. Okay, I'm sure you have some questions. What if, right? What if?